A statistical analysis, impact of weather in homogeneity of COVID-19 variations in India. Abstract coronavirus recently has become a unique universal severe problem required much attention of researcher to come out with optimum solution. The specific intention of this research is to make comparison and test the homogeneity of various averages. Analyses of Variance, Anova, by using the RStudio and tests concerned to the effects of weather in corona spread were observed. Over the rapid increase in daily and widespread active reported positive cases of COVID-19 in the set of 3 neighboring states of India were observed. Objective of this paper is to find indication and homogeneity of COVID-19 variations under the specific weather effects with the conclusion at 5% and 1% level of significance. Keywords, statistics, p-value, COVID-19, weather, RStudio, Anova. 1. Introduction. Coronavirus disease 2019 is described as severe acute respiratory syndrome coronavirus 2, SARS-CoV-2, 2019 Gov previously. When a new virus comes in existence, for the cope up, we have to much more familiar about its consequences. As we already informed by media and medical staff that most respiratory viruses are spread by large droplets that come out when people cough and sneeze and stay in the open sky air usually for about 6 feet in front of them. They land on metal surfaces and transmitted between one human to another human by touching those metals, instance door latch or any other surfaces. Rest viruses can widespread in the atmosphere and remain up for a longer duration in the form of tiny droplet nuclei. The whole world has put glances on the second most populated entity, India, which is having about 17.7% of the global population. Till 22th June, recorded total of 426,197 confirmed cases and 13,707 reported deceased all over country. This deplorable situation informs about future outbreaks. Present published studies have acknowledged that the widespread of COVID-19 is supposed to be more in the cold climate than the warm and hot climate, regular with seasonal flu, Bloom-Feshbach et al., 2013. Many viruses from the corona group, with the SARS-CoV-1 along with MERS-CoV, also illustrate seasonality and inclination for minimum temperature as well as humidity, Anova et al., 2010. The SARS-CoV-2, which is known as COVID-19, has been examined to be like that of SARS-CoV-1 on many types of metal surfaces in particular weather, Van Dory-Malen et al., 2020. Sejati et al., 2020, have examined the average temperature and concerned humidity in many parts of the globe from November, 2019 to Feb. 2020 and examined the widespread particularly in the entities lying in among latitudes 30-50 degree north, and having concerned similar weather functioning. In another observation, Oliveros et al., 2020, recorded the impact of similar temperature, humidity, and wind velocity on the rate of COVID-19 infection in China during January 23 to March 1, 2020. The rate of augment and doubling duration of corona patient cases were examined and classified with the weather inputs using linear regression study. The consequences have indicated that the doubling duration of the corona patient cases were positively correlated along with temperature as well as negatively correlated with humidity. Though, these concerned correlations numerical were less, R2 0.18, to describe any positive conclusion. Precipitation and wind velocity were established to exhibit no correlation with the doubling duration of the corona patient cases. Bukhari and Jamil, 2020, observed the impact of humidity as well as temperature on the rising COVID-19 worldwide cases during January 2020 to March 19, 2020. The observations have indicated absolute humidity as best metric compared to relative humidity as well as temperature or weather for study purpose of this spread. It was also examined that 90% of the new infected cases up to March 21, 2020 had arisen within a definite range of A, 4 to 9 G/M3, as well as T, 3 to 17 degrees Celsius. Further, many other observations may help us to enhance our perception on the realistic impact of weather and temperature on the widespreading. 2. Objectives. The specific objectives of this observation is to measure and make precise comparison under the effects of COVID-19 reported cases at non-similar weather in the 2 set of 3 neighboring states in India. The objectives may be accomplished through the following objectives. I. To make comparison in COVID-19 cases due to weather at Gujarat, Maharashtra, and Tamil Nadu. 2. To make comparison in COVID-19 cases due to weather at Delhi, Rajasthan, and Madhya Pradesh. 3.1 Hypotheses 1. IH0, there is no significance effect on COVID-19 reported cases in different level of weather. 2H1, there is significance effect on COVID-19 reported cases in different level of weather. 3.2 Hypothesis 2. 3H0, there is no significance effect on the increase in COVID-19 reported cases in different level of weather. For H1, there is significance effect on the increase in COVID-19 reported cases in different level of weather. 3.3 Hypothesis 3. VH0, there is no significance effect on the two sets of states concerned to COVID-19 reported cases and their interaction with different level of weather. 6H1, there is significance effect on the two sets of states concerned to COVID-19 reported cases and their interaction with different level of weather. Significance level. We have used 5% level of significance throughout this study. For data analysis for Gujarat, Maharashtra, and Tamil Nadu. Table 1. Summary of Anova 1. DF sum SQ mean SQF value PR, F. Weather 19.414 E plus 089413998135.105.44 E13. State 14.717 E plus 084717222129.611.44 E07. Residuals 213 3.393 E plus 0915928673. Significance codes 00.0010.01 asterisk 0.05 dot 0.11 Table 2 Summary of Anova 2. DF sum SQ mean SQF value PR, F. Weather 19.414 E plus 08941399813363.311.05 E13. State 14.717 E plus 084717222131.735.60 E08. Weather, State 12.407 E plus 08240705093169.197.98 E05. Residuals 212 3.152 E plus 0914868406. Significance codes 00.0010.01 asterisk 0.05 dot 0.11. Interpretation of Result 1. In Table 1 and Table 2, the Anova analysis shows that the different level weather in Maharashtra, Gujarat, and Tamil Nadu is directly proportional to the COVID-19 reported cases. The effects of each level of weather on the rate of COVID-19 cases are proved to be statistically significant. Therefore we have sufficient statistical evidence at 5% significant level to reject the null hypothesis and concluded that there is significance effect of weather level on the cases of COVID-19 in these mentioned three neighboring states of India. Additionally, the possible values of weather, state, and their interactions clearly indicate a very strong significance in this study. Figure 1 has depicted equally pattern among all the variables. Figure 2 describes cumulative and daily reported cases of COVID-19 on three neighboring states which distributed equally pattern among the variables. Figure 3 has revealed residuals plot of the analysis on weather and states serves as additional evidence in justifying the alternative hypothesis. Fig 4. Residuals plot of the analysis on cumulative and daily reported cases of COVID-19 and states. Interpretation of Result 2, dependent on the possible values in Table 3 and 4, the analysis shows different level of cumulative and daily increased COVID-19 reported cases in Maharashtra, Gujarat, and Tamil Nadu is statistically significant. The effects of each level of reported COVID-19 cases are proved statistically significant. Therefore we have sufficient statistical confirmation at 5% significant level to reject the null hypothesis and concluded that there is significance effect between the cumulative and daily cases of COVID-19 in these mentioned three neighboring states of India. Further, the possible values of cumulative and daily reported cases, state, and their interactions clearly indicate a very strong significance in this analysis. Figure 4 shows residuals plot of the analysis on cumulative and daily reported cases of COVID-19 so states serves as additional proof in justifying the alternative hypothesis. The possible values in Table 5 and 6, the analysis shows the different level weather at Delhi, Rajasthan, and Madhya Pradesh is statistically significance of COVID-19 reported cases. The weather effects on the COVID-19 cases are proved statistically significant. Therefore, we have sufficient statistical evidence at 5% significant level to reject the null hypothesis and conclude that there is significance effect of weather level on the cases of COVID-19 in these mentioned three neighboring states of India. Further required values of states' weather and their interactions clearly indicate a very weak significance in this analysis. Figure 5 depicts the box plot of COVID-19 cases, three neighboring states on their level of weather which distributed equally pattern among these variables. Figure 6 describes the cumulative and daily reported cases of COVID-19 on three neighboring states which distributed equally pattern among the variables. Figure 7 shows the residuals plot of the analysis on weather and states serves as additional evidence in justifying the alternative hypothesis. Interpretation of Result 4. In Table 7 and 8, this analysis shows different level of cumulative and daily increased COVID-19 reported cases in Delhi, Rajasthan, and Madhya Pradesh's statistically significance. The effects of each level of reported COVID-19 cases are proved to be statistically significant. So, we have sufficient statistical evidence at 5% significant level to reject the null hypothesis and concluded that there is significance effect between the cumulative and daily cases of COVID-19, in these mentioned 3 neighboring states in India. Further, by the values of cumulative and daily cases, state, and their interactions clearly indicates a very weak significance in the analysis. Figure 8 reveals the residuals plot of the analysis on cumulative and daily cases of COVID-19 and states serves as additional proof in justifying the alternative hypothesis. Conclusion. In this study, we have discussed the comparison of COVID-19 cases due to weather at Maharashtra, Gujarat, and Tamil Nadu as well as Delhi, Rajasthan and Madhya Pradesh. The distribution of new corona cases examined between March 23 and June 15, 2020 across all mentioned states. Through statistical precise analysis, we have identified the vulnerable ranges of weather variables and validate them. Using our calculations, we have examined comparison among most infected states in India, which may be more dangerous for the transmission of corona in the present and arrival months in 2020. We predicted our results are not only be beneficial to the mentioned states, but also rest states which are supposed to wide infected soon due to weather conditions in 2020, to get ready socially, medically, and economically against mass and wide spreading of novel COVID-19.